This is a video on integrating by switching the order of integration. The question states, integrate the double integral from 0 to 1 and from 2y to 2 of e to the x squared dx dy. So if we try to integrate e to the x squared dx, we won't succeed. This is one of those impossible integrals. There is no closed form solution. So instead, let's try switching the order of integration and see if we get lucky. So I need to sketch the picture. Since we have a dx dy, we know that we have x is a function of y. So the left bound will be x equals 2y, and the right bound will be x equals 2. And then y will be as low as 0 and as high as 1. So I sketch that picture. Since I have dx dy, the little man is lying down. Here's x equals 2y at the feet. Here's x equals 2 at the head. So I want dy dx instead of dx dy. So I take the little man and I stand him up, like so. So now I can look at the feet and the head, but the head, this curve x equals 2y, doesn't work for me because I want dy dx. So I need y in terms of x. So just divide by 2. And I get y equals x over 2. And now I can switch the order of integration by saying the little man's feet are at y equals 0, and the little man's head is at y equals x over 2. And then the farthest left the little man gets is 0, and the farthest right the little man gets is at x equals 2. So here's my integral where I've switched dx dy to dy dx, and I have 0 to 2 and 0 to x over 2 e to the x squared dy dx. And now I can integrate because e to the x squared is a constant with respect to y. So its integral is just y times e to the x squared. And I'm going from 0 to x over 2. So I plug in. I can plug in x over 2 for y, and I can also plug in 0 for y, and notice that that part just goes away, it zeroes out. So what I get is I can pull the over 2 out as a 1/2. There's my x. And I'm still integrating from 0 to 2 of, again, x e to the x squared dx. And this is something I could integrate because I can use u substitution. I can let u equal x squared, and du is 2x dx. And notice I have this x available for me. I need to deal with the 2 by dividing by 2. So 1/2 du equals x dx. And now I'm ready to substitute. So first thing, the 1/2 gets pulled outside. 1/2 times a half is a 4th. Then I have x dx. X dx becomes a du. The 1/2 already got pulled out. And then if x is equal to 0, 0 squared is 0, so the lower bound is still 0. And if x equals 2, 2 squared is 4, so the upper bound becomes a 4. And I have e to the x squared, that becomes e to the u, du. And this is an easy integral. The integral of e to the u du is just e to the u. So I get 1/4 e to the u from 0 to 4. And now I plug in, and we get e to the 4 is just e to the 4, and e to the 0 is 1. So that gives me that this double integral is equal to 1/4 times e to the 4th minus 1. And I'm done with the problem.